All right, so this video is going to focus on what we call the work problem. So this problem here is a word problem. It's an application problem that tends to get grouped together with rational expressions, but a lot of the problems tend to be worded almost the same. There is a specific formula that you do need to know in order to solve this type of problem, but let me first get through reading the problem. That way you're a little bit familiar with what kind of problem this is, and then we'll talk about how do we solve this thing. So in this problem here, we're talking about Brian and Peggy, and they're cleaning their house. It says that Brian could clean it in 24 minutes working alone, but Peggy could clean it in 21 minutes working alone. But the question says, how long would it take them if they worked together? So there's a lot of different problems out there where you're talking about two different people doing one job. One person could do it in this time, one person can do it in, this other time here, but how long would it take them if they worked together? So this is called the work problem here. And there is a little formula that you do have to kind of know in order to set this problem up and go about solving it. So that problem looks like this. So you have your x over time alone plus x over time alone, and that's going to equal to 1. So this is pretty much the setup for every single one of these problems. Now what the x's represent, the x's represent the two different people. This first x here is Brian, this second x over here is Peggy. So it says here that Brian could do it in 24 minutes. So I'm just going to say that this first fraction represents Brian, this second fraction over here represents Peggy. So Brian can do it in 24 minutes. So underneath Brian's x over here in time alone, I'm going to input 24 because it says Brian could do it in 24 minutes. My second fraction, which represents Peggy, well, Peggy could do it in 21 minutes. And then we're going to set this all equal to 1, and we're going to solve this equation here. So when we solve this equation for x, we're going to figure out how many minutes it's going to take them to do it together. Now, let's focus on how do we solve this type of equation here. So when I'm looking at this equation here, the first thing that probably most people notice about this problem here is, darn it, there's fractions in it. We have these fractions here that we have to deal with. And normally when it comes to equations with fractions in it, the best thing to always do is to get rid of those fractions. So we want to get rid of these fractions to make our life easier, to make the solving portion of this that much easier for us to do. Now, the way that we get rid of fractions is by clearing fractions. So essentially, the rule for clearing fractions says that we want to multiply our entire equation. So I want to multiply this entire equation by my lowest common denominator. Well, that means I have to know what my lowest common denominator is, right? So if I'm looking at my denominators of a 24, a 21, and then technically a 1 over here, because remember, anytime we make a whole number into a fraction, we can make it into a fraction by putting it over 1. So we need to stop for a second and think, okay, 24, 21, 1. What is my common denominator here? Okay, so let's see. We got to rack our brains for a little bit here and think, what is the first number that a 24 and a 21 has in common? So we need to do times tables here, 24, 48, and so on. 21, 42, 63, and we need to list our times tables for these two numbers here until we come up with one that they both match up together. And let's see, I'm trying to rack my brain here to try and come up with this number here, but I believe the first number that they both have in common, and please correct me if I'm wrong, but the first number that 24 and 21 has in common is 168. Okay, a little bit of a big one, but that's okay. So if 168 is our common denominator here, what we're going to have to do is we're going to have to take 168 and multiply to everything in this equation. Now, I always like to put my number over a 1 just so I can keep my fractions straight and I know what I'm multiplying. Because remember, when it comes to multiplying fractions, it's numerator times numerator, denominator times denominator. So when I go through and multiply here, so this is 168 times x over 1 times 24, which is 24, plus 168 times x over 1 times 21, which is 21, is equal to 168 times 1, which is 168. Okay, and I'm drawing out, I'm kind of writing out the multiplication in the long ways here just so you can kind of see what's going on. But our next step here, and some people can jump straight to this step here, is actually simplifying this. What our hopes are is that when we simplify this down, we should be left with whole numbers, which is going to make this problem a lot easier for us to solve. Now, if we take 168 and divide it by 24, we should get a 7, and then drop down the x with it. Plus 168 divided by 21 is an 8, and drop down the x with it. And then that's all going to equal 168. So if we combine our like terms here, 7x plus 8x, we should get a 15x divided by the 168. And then the only thing left to do here to solve this problem, remember this 15x is 15 times x. So the opposite of multiplication is division. So we're going to divide both sides by 15 to give us that x is equal to, I'm going to have to pull out my handy dandy calculator for this one. Let's see, 168 divided by 15 is 11.2. So what this means here is that if it took Brian 24 minutes by himself, and if it took Peggy 21 minutes by herself, it would take them both 11.2 minutes if they worked together and both got the job done.